I would not say that at all. Um, you guys are definitely in an intelligent group of students. So, um, okay. So today we are going to look at solving trigonometric equations that are more challenging than yesterday. So yesterday was really intended to be pretty straightforward. Today is intended to be more challenging. So what makes the first example different from the ones we looked at yesterday? Yeah, so you have a number in front of theta, and that causes an issue. We start out the same as we did before. We subtract 2, and we get 4 sine of 2/3 theta is equal to -2. We divide through by 4, and we get sine of 2/3 theta is equal to -1/2. Now the question is, where is sine negative? In which quadrants? The bottom quadrants, yes. So sine is negative down here, okay? And the key is that in order to get to the 2/3 theta, I need to remove sine. So I'm going to show the actual mathematics that's happening. You don't have to write this down because this should really just kind of be in your brain. But in order to get to the 2/3, I sine inverse and I sine inverse. Okay? And what happens when we sine inverse? That's gone, and we're left with 2/3 theta equals sine inverse of -1/2. So I don't actually write that out because when we make these quadrants like this, that's when we actually do the sine inverse. So what is the sine inverse of 1/2? You all have this memorized. 30, very good. So this angle is 30 and this angle is 30. So you can do that on your calculator, or maybe you have them memorized. A lot quicker if you memorize them. So the sine is now gone. I have 2/3 theta equals, and I have 2/3 theta equals. So 2/3 theta is equal to what? 210. Because you were 30 degrees past 180, and 330 degrees because you're 30 degrees back of 360. So now the last step is just to solve for theta. Times by 3/2. So theta is equal to, if we take 210 and we multiply by 3, we get 630 divided by 2 will be 315. And when we take 330 and we multiply by 3, we get 990 divided by 2 is going to be 495 degrees. And so as you examine these solutions, you see theta is equal to 315 and theta is equal to 495. Now, from the outset, I ask you to solve for theta between 0 and 360. Are answers between 0 and 360? They aren't. So just to clarify my expectation, because we're kind of all over the board here, what I really, really want is that when you set this part up, I want you to set up solutions that are between 0 and 360, okay? So I multiply both sides by 3/2. You're going to want to either divide by 2/3 or multiply by 3/2. Yep. Okay, so when I originally set up the problem to solve, you can see that 2/3 theta is 330, 2/3 theta is 210. Those are the numbers I'm looking for to be between 0 and 360 when you're doing your solution. Because if you notice in the answer key, if you came up with, say, 30 degrees for a solution, the book would not list 30 degrees solution, but they would list pi over 6. And furthermore, they would list all the solutions, which would be pi over 6 plus any integer number times around. So it lists as 2 pi k if you check that. That means that I can do pi over 6, which is right here, or I can do pi over 6 plus 2 pi, or pi over 6 plus 2 pi plus 2 pi, or pi over 6 plus 2 pi plus 2 pi plus 2 pi plus 2 pi. So it would just keep on giving you an infinite number of results depending on what integer k is. Okay? All right, let's look at one that's more difficult because I can see you guys thought that was way too easy. So let's look at problem number 2. Any idea? Okay. So before we divide by a cosine, I just want to caution you. X squared equals x. How many solutions are there? There are two. X squared minus x is equal to 0. Factor x times x minus 1 is equal to 0. So you can see that there are two solutions. If I were to divide by x instead, I would get x is equal to 1. Well, all of a sudden, I only have one of the solutions. What happened to the other solution? I lost it. So I remember getting this type of problem when I was in high school, and many times I would do problems differently than how a teacher described because I kind of had my own way of doing things, and most of the time it was pretty good. But in this situation, I remember I lost many solutions. There was a problem I encountered that had 6 solutions, and I only came up with 2 solutions. I left a number of pieces off, and so it's definitely a scenario where instead of dividing by cosine, we want to subtract the cosine over. We get 2 cosine squared of 3 theta minus cosine of 3 theta is equal to 0. Now, instead of dividing, I will factor. I'll take out a cosine of 3 theta, and I'm left with 2 cosine of 3 theta minus 1. Okay, so I set these two equations equal to 0. Cosine of 3 theta is equal to 0. And 2 cosine of 3 theta minus 1 is equal to 0. So let's focus on the first one. Cosine of 3 theta is equal to 0. Yep, very good. So where is cosine equal to 0? At 90 and 270. Remember the little chart we made yesterday in class for tangent and sine and cosine? So I inverse cosine, and if you remember, cosine is equal to 1 at 0 degrees. It's equal to 0 at 90 degrees. It's equal to negative 1 at 180. It's equal to 0 at 270, and then 1 at 360. In order to solve them, we divide by 3. And so we get theta is equal to 30 degrees and 90 degrees. Yes. So really all I've done, if you guys kind of just look at it, all I've done is I've just listed the coordinates without the y values. So this is 1, 0, this is 0, 1, this is negative 1, 0, and this is 0, 1, right? And since cosine is the x value, that's what we're looking for. So sine, you would just do the y values. And for tangent, you would just do y divided by x. So it's all related. Okay, the next one, I add the 1, I divide by 2, I get cosine of 3 theta is equal to 1/2. Well, in which quadrants is cosine positive? 1 and 4. So if you inverse cosine of 1/2, 60. So therefore, you have 3 theta is equal to 60, and 3 theta is equal to 300. Divide by 3, and you get 20 degrees and 100 degrees. You can just type it in. So if you do cosine inverse of 1/2, you'll get that 60 degrees. Good? Yeah? What do you think about that, Eve? Okay. What's your favorite ice cream? Cookie dough. Okay. So on a scale of 1 to 5 for ice cream, you would rank cookie dough a 5. Is that correct? So where would you rank this stuff on the cookie dough scale? A 2. Okay. All right. Good. I thought you were going to give negative results. So thank you for being positive. Because that way we would speak forth our distaste in a usually we like to exaggerate situations. Exactly, it's not mathematically correct. Okay, What's different about example 3? You know, it's interesting. Everybody focuses on the square root. Square root's no big deal. Yeah, the big issue is that we have two different trig functions. We have a cosine and we have a sine. So what are you going to do? Okay, Chris has a good idea. Square both sides. That will work. However, so I get negative root of 3 is equal to what sine divided by cosine? Hey, isn't that nice and tricky? Look at that. Huh. Isn't that smart? Well, where's tangent negative? Second and fourth. Inverse the root of 3 on your calculator for tangent, and what do you get? Very good, 60 degrees. So therefore, I have x is equal to 120 and 300. Nope. I'll have to get Jill. Hey, Jill, can you come on in and settle an issue for us? Okay, we look at number 4. Cosecant and sine. What are you going to do now? You are both correct. I'm going to choose 1. 1 over sine of x over 2 is equal to 2 sine of x over 2 over 1. Yes. So we don't switch the angle. Would you agree that cosecant of x is equal to 1 over sine of x? Well, it's not like when you flipped it, you then made it 1 over x, right? You don't flip the angle. Yes. Okay. So now what? Cross multiply. 1 is equal to 2 sine squared of x over 2. Divide by 2, 1/2 is equal to sine squared of x over 2. So it's being squared. So plus or minus the root of 1/2 is equal to sine of x over 2. Well, where's sine positive? Where is it negative? So the square root of 1/2, that's the same as 1 over the root of 2, right? It's the same as root of 2 over 2. Sine inverse. Where is sine equal to root of 2 over 2? 45. If I go sine inverse of the root of 2 over 2 on my calculator, I come up with 45. Well, it's still there. So we inverse sine, so sine is gone, so we've got x over 2 is equal to 45. We've got x over 2 is equal to 135. X over 2 is equal to 225. And x over 2 is equal to 315. So 45. Yep, it just gives you that reference angle. Yep. Yep. Multiplying by 2, and we get x is 90, 270, 450, 630. Isn't this fun? Okay, Eve brings up a really good point. She says, I thought this was supposed to be challenging. So we will ask Eve how to solve the next problem. I plug it in the end. She says, I plug it into my calculator. Very good. So, yeah. All right. If you want to solve this algebraically, can you tell me? And yes, we solve this with our calculator, no problem, no big deal. All you do is just set sine of 2x equal to cosine of x, and you'd see where they intersect. Or you would type this into y equals, and you would see where it crosses the y-axis, right? That's it. Yeah. But that would give you an approximation. We would like exact values. Can somebody tell me by looking at here, what is the issue? Why is this difficult to work with right now? Yeah, I've got a double angle and a single angle, and that's a big issue. If only there was something in trigonometry where they allowed you to convert from like double angles to single angles. Like if a teacher had somehow given you a sheet of notes where it talked about double angles becoming single angles, like then that would be really useful. Hey, wait a minute, it's right there. Hey, I did my job last week. Way to go, Gens. So there we have it. Let's use it. I can convert to a single angle. Instead of sine of 2x, I have 2 sine of x times cosine of x minus cosine of x is equal to 0. So in order to have any shot at this problem, you have to first recognize that you have to substitute an identity that you maybe didn't see right away. So I've substituted the identity. Now, in order to get the problem, you have to recognize something else. What do I need to do next? Factor out a cosine of x. Those are 2 pieces you have to see. If you don't see them, you really can't do much with the problem. So where is cosine of x equal to 0? Did we already cover that in a problem earlier? Yes, we did. We got x is 90 degrees and 270 degrees. And the next one is 2 sine of x minus 1 is equal to 0. How do I solve that? Add 1. Where's sine positive? 1 and 2, sine inverse 1/2, and I get 30. Grace has that one memorized. Good job, kiddo. So I'm going to put down 30 and 150. Sweet. I really don't even know. Okay, see sine of 2x there? Right, because it's equal to that. So sine of 2x is 2 times sine of x times cosine of x. Cool. Okay, Miss Genius. How about number 6? What if you can't do? What if I say find an exact value? Stop with this calculator garbage. Oh, okay. So it's a little bit more challenging, huh? So any thoughts? I don't have a substitution for sine or cosine. -1? Why? We need a square, don't we? Square it up. Square it up, dude. Yeah. Square it up. Here we go. Sweet. Well, let's think about it. Look, folks. Second level. What's a great thing to do? Model with an easier problem. So let's just take x equals 3, okay? Are you allowed to square both sides? Yeah, but we added a solution, didn't we? So this one has one solution, this one has two. So we got to be careful in our final result. We have to consider, well, maybe we added a solution that doesn't exist. So we'll just check our answers in the end and make sure we're good to go. But yeah, squaring both sides of an equation, that's legit, you know, so we're good. Okay, so square the right. No, I'm never sarcastic. Like, I'm the least sarcastic teacher in this school. Oh, oh my goodness. All right, we square this side, cosine of x plus 1. How do you do that? Oh, somebody's a little angry now. All right, so now what? Why did you want to square both sides? What was the whole point of squaring both sides? So what do you put in for sine squared? How about just 1 minus cosine squared? So now I have cosine squared of x plus 2 cosine of x plus 1 is equal to 1 minus cosine squared of x. What do I do to both sides? Sure, subtract the 1's. Those are gone. And so I have 2 cosine squared of x plus 2 cosine of x is equal to 0 when I add that cosine squared over. Now what? 2 cosine of x times cosine of x plus 1 is equal to 0. What? Is divide through, then you would lose a solution. And you would never find it. Okay. Yeah, you can divide by 2. That would be fine. Sure. The 2 because there's no variable involved in it. But you can't divide by 2 cosine of x. The 2 you can get rid of, yep. So, where is cosine of x equal to 0? Yeah, 90 and 270. And then cosine of x plus 1 equals 0. That means where is cosine of x equal to -1? So it looks like we maybe added a solution that shouldn't be there. We won't know unless we plug it in. So let's go back to the beginning. What's the cosine of 90? Plus 1? What's the sine of 90? Did that work out? Keep it. What's cosine of 270? What is sine of 270? Let's plug in 180. What's the cosine of 180? Plus 1? And what's the sine of 180? So we have 90 and 180. But if somebody has just a little bit different, again, always check your answers. That maybe somebody sees from the outlook that this problem really has another really great way of being modeled or argued. Like if we just think of this as a graph, say sine of x, and it has an amplitude of 1 and has a period of 360, and I divide that up into my 4 quadrants, you notice here that the graph looks something like that. Is that everybody in agreement with me? And if you consider cosine of x plus 1, well, that's just shifted up 1 unit, isn't it? And it would start up here, then it would drop down, and it would drop down, and it would come back up, and come back up. So if we were to look at that graph, the question is really where are those two graphs equal to each other? And it's very apparent to see it's 90 and it's 180. I doubted you, I'm sorry. Let's do the very last problem. No help from Mr. Gens. We've just got to figure it out. Okay, turn the tangent into a thinny thing. I need a little bit more direction than that, okay? Okay, so you want to go cosine of x plus sine of x times sine of x over cosine of x is equal to 2. Is that right? Now what? Okay, so cosine of x plus sine squared of x over cosine of x is equal to 2. Is that what you want? Okay. Oh, so you put that over 1 and you multiply the top and bottom by cosine? Okay, we can do that. So, okay, so GG sounded angry there, but we're gonna. All right, so you got cosine squared plus sine squared over cosine is equal to 2. You're okay with that? Okay, and then you said what? Okay, so we get 1 over cosine. Okay. Okay, so you chose to cross multiply. Okay. And now you're trying to identify where cosine is positive. Okay, you inverse, you got 60, so 60 and 300, good. Okay, wow, well. Okay, so that seems like a good option, but like we made about 5 like legal mistakes along the way, okay? So yeah, I mean, you guys had really good like focus and effort and like, but I mean, there was about like, no, I'm kidding, everything's fine. It's just it's all perfect. Yeah, you guys are great. Yeah, so I don't know, this is great. You guys did great work. Good job. Really, no help from me. You guys just plowed right through it. Way to go. I'm very proud of you. Hey, you aren't allowed to talk for the rest of the hour. Okay, all right, you are not. Okay, all right, or next hour for that matter. All right. Or ever again. 7.5, page 579, numbers 21 through 31. We have Office Friday this week, you guys. I know. Maybe we can do Office Thursday. So, what? Okay. All right. So this is your assignment. I just want to caution you guys. Okay. this is where you need to kind of check your ego at the curve and realize that some of these problems, they are challenging. And if you get them all, you're like, no big deal. Well, try a few more problems out of the book and see if you can find one that really stumps you. There are some challenging problems. And I realize that not everybody's gonna be able to get all of them without, either A, asking for help, or B, checking the solution manual or something. So, but we'll see what we can do. So there's your assignment. We have one more lesson. That's tomorrow. Okay. And then we're gonna do some ACT stuff on Thursday. No school on Friday, Saturday, Sunday. ACT on Monday. ACT test on Tuesday. And then you'll have the study guide to work on Wednesday and Thursday, and your test next week, Friday.